this lesson is on trigonometry. Now, trigonometry is all to do with right-angled triangles and specific ratios. We have three special ratios which we work with when we look at right-angled triangles and trigonometry. The names are the sine ratio, the cosine ratio, and the tangent ratio. They're the three ratios, and basically it's to do with the sides on a right-angled triangle. What you've got to get very, very good at doing is being able to label right-angled triangles confidently. So, what's the side that I always label first? I always label the side opposite the right angle. And by the work that we've done on Pythagoras, you should be able to realise that is always called the hypotenuse side. So this side here is called the hypotenuse. I'm just going to abbreviate it down to the letter H when we start doing the questions. H for hypotenuse. Then what do? Is I go to a angle that I'm given or asked to find. In this particular case I'm telling you this is 45 degrees, and I label the side that's opposite that angle. So the side that's opposite that 45 degrees is this side here. So this is called the opposite side. And then that only leaves one side left, which is called the adjacent side. The adjacent side being the side next door to the angle. So this is the adjacent side. So let's just go through that again. I would start always with the hypotenuse. I'd then go opposite the angle, and then I'd go for the side which is next to the angle. Okay, so what's trigonometry all about? Well, basically, if you imagine, okay, we've got a 45 degree angle here, then this would be a perfect square. So you're cutting through at 45 degrees a perfect square. So you could have these sides to be 1 and 1. 1 centimetre, 1 centimetre. What you could do is you could expand this diagram and make these sides 2 and 2, or 3 and 3, or 4 and 4, or 5 and 5. But I guarantee you're going to make a right angle and you come off at 45 degrees, that adjacent side and that opposite side have to be the same length. Okay. Now what you've got here is a whole range of different triangles that are 45 degrees with a right angle, and what basically happens is that the ratio, these three ratios, give exactly the same answer, a same number. So if we look at the tangent ratio first, the tangent ratio is the opposite side divided by the adjacent side. So, if the side was 1 and 1, 1 divided by 1 is 1. If it was 2 and 2, you'd still get 1. If it was 3 and 3, you'd still get 1. 4 and 4, you'd still get 1. So what we're trying to say there is that the tangent of 45, so literally the tan of 45 degrees is 1, whatever size you make that triangle. So long as it's got a right angle, so long as it's 45 degrees, it will always be 1. Always. But not only is that ratio, okay, going to be the same for 45 degrees, if we look at this ratio here, the sine ratio is the opposite side divided by the hypotenuse side. Now it doesn't come to 1. You can see it's not going to be 1. But if I do a bit of Pythagoras just to show you, remember that squared plus that squared fits perfectly into that square. And then we square rooted when we did the Pythagoras lesson. So what we're doing here is 1 squared plus 1 squared, square rooted gives me that length. 1 squared's 1, plus 1 squared's 1, 1 plus 1 is 2. So this hypotenuse side is the square root of 2 if that is 1 and that is 1. So if you look at the sine ratio, which is the opposite side over the hypotenuse side, the opposite side is 1, the hypotenuse side is the square root of 2, so the sine of 45 degrees is in fact 1 over the square root, okay, of 2. If you type that into your calculator, it comes to 0.7071. 0.7071. Now, not only will that be for the 1, 1 triangle, I guarantee if we did 2, 2, 3, 3, 4, 4 and applied exactly the same process, I guarantee if you did the opposite side and you divided it by the hypotenuse side, it will always make 0.7071. So what we're saying is the sine of 45 degrees in whatever right angled triangle you want, okay, will make 0.7071. If we look at this ratio, the cosine ratio. If you look at the cosine ratio says to do the adjacent side divided by the hypotenuse side. There's the adjacent side, which is 1. There's the hypotenuse side, which is square root 2. So if you notice, the cos or cosine of 45 degrees is also 0.7071. 1 divided by the square root of 2, because that's the adjacent side, that's the hypotenuse side, comes to 0.7071. So that's quite important because that allows us, if we've got right angled triangles, to calculate missing angles and missing sides because we know these ratios are holding the same. But we haven't just got one for the sine of 45, for the tan of 45, for the cos of 45. We've got it for any right angled triangle with any angle in. So if you imagine now, I drew a triangle, okay, and this was 60 degrees, okay, and we were working out ratios. So if I wanted to work out the opposite over the hypotenuse, there's my opposite side, there's my hypotenuse side, and I drew a triangle, 60 degrees with a right angle, and I guarantee if I measure this opposite side and I measure this hypotenuse side and I divide the two numbers, they would come to a single number, whatever size I make the triangle, as long as it's got 60 degrees and as long as it's got a right angle. Okay, so I'd have a different opposite side, I'd have a different length for this side, but I guarantee when you divide the two numbers together, they come to exactly the same number. How do you access that number? It's quite simple. All you do, type into your calculator, sine of 60, and that will come a number. And that number is the ratio, okay, of the opposite side divided by the hypotenuse sides. Same with cosine, same with tangent. You've got it for all the angles. We're about to do some questions now to do with missing sides. What you need to do though is to remember these three ratios. There's various ways of remembering them, okay? The most common way I've come across is to use this. So for the sine ratio, sine is opposite over hypotenuse, C-A-H, for the cosine rule, adjacent over hypotenuse, and TOA for the tangent ratio, opposite over adjacent. So, TOA. You could make words up. Silly old Harry caught a haddock drawing off America. Various ones that you can use. I tend to use those TOA. And what's very, very important is after you get used to labelling triangles, deciding which of these three ratios you're going to use to calculate missing sides. And that is the key, okay, to trigonometry. Calculating missing sides and missing angles using the appropriate ratio. And that's what we're going to look at next.